Okay, thank you for having me at the GraphQL Summit. When I was learning GraphQL, like most people, over the past year or so, I ended up watching a bunch of talks from last year's summit on YouTube, so it's kind of surreal to be here now. But I'm here from the New York Times, or as our president says, the failing New York Times. So hopefully we're not failing technologically. But I'm Scott Taylor. I am a software engineer on the web frameworks team at the New York Times. I'm also a member of the WordPress core team. I led a release of WordPress a couple years ago. But I'm really just a big fan of open source software. And I'm really delighted to see Facebook recently adopt the MIT license for all these projects that we use and love. So I'm glad that got settled in some form or fashion. Applause, right? I'm also a musician. I always say mainly, but I spend a lot of time coding. But you can find me on Twitter at Wonderboy Music, which is my fake booking agency from back when I played in a band a lot. And then I'm S. Taylor on GitHub. My wife and I live in Brooklyn, and just quickly, here's our cats. We have Waffles, Willa, Feline Dion, and Barry Manilow. So I'm here to talk about our use of and switch to GraphQL and React in the present and future at the New York Times. 100% of the New York Times is not on GraphQL yet, but I envision a future where it is. And currently, we're in the middle of something many of you may be familiar with, which is a replatform. And as we all know, these things never go as planned. They always take way more time than anybody budgeted for. But in the midst of these soul-searching adventures, we learn a lot along the way. So for us, pretty much everything is changing. But until everything is completely changed, and 100% of our traffic points to the new platforms, we still have the old platforms. So even more challenging is supporting these old and new platforms at the same time. But at a high level, our goals, regardless of what technology we're using, is to simplify our stack. This idea that is there one place we can add and retrieve data? I think we all know any company we've worked at, when we spin up a new project, a lot of times we hunt down the REST APIs, we figure out if we need authentication, and then we're writing the 17th version of the HTTP client that talks to that service. So is there a way we can not do that? We also were interested in like a common language and repository for creating and reusing components. What happens a lot is we build what we think is the perfect monolith, and then we need something that doesn't work with the CMS or is slightly different, and somebody may end up spinning up a completely new project that may copy paste a lot of code between frameworks, and that happens at the Times way more than it should. And how do we make onboarding easier? So if I come to the Times, it would, if I'm a new employee, wouldn't it be great if I could sit down and within minutes spin up a node server and be hacking and looking at GraphQL and building apps? So that would be a really nice feature. So this is our current platform, which we'll refer to as old, but it's still current. So hopefully you recognize our homepage. That's the result of our last replatform, the current iteration of the New York Times you see today. And if you're a part of the allocation, you may see our new design. But it wasn't that long ago that we were working on our last replatform. It was a PHP platform we launched about 3 or 4 years ago. And I like to say, I remember being at the Champagne Toast for this replatform, where our CEO was like, oh, congratulations, it's so beautiful. We're never going to take this long on a project ever again. And the interesting thing is we're already that same length of time into this replatform, which is fine. It's going to be worth it this time for sure. So why replatform? And there are some really good reasons to replatform. And one of the main ones is consistency. So when we change designs, maybe a design pattern or a design language, we want it to be reflected across our entire suite of projects. We don't want to have to touch 5 or 10 code bases to make a design change. Or if we don't set up these frameworks properly, a completely unrelated change may require us to push 6 projects to production. We don't want to do that. Right now, our desktop and mobile apps are actually separate code bases and separate projects. So the project I'm working on is really, at its main reason is putting those into one app. Our iPhone and iPad apps have actually recently been rewritten as one app in Swift. Believe it or not, those were two separate code bases for a long time. And what we're trying now is our Android and iOS apps are actually rendering HTML web views for their content, so that we can change that in one place and push those design changes without having to do an app store refresh or anything. One day this could be React Native, but so we're really trying to condense the number of places we have to change when we make changes as a company. A few technical things, like while we're doing this, we're also doing some other big projects. We're moving our data center apps to Google Cloud Platform. And the New York Times actually has some great plugins I wanted to shout out for interacting with Google Container Engine and Google App Engine and stuff. Our data internally is moving to this great kind of like data pipeline written on Kafka and using protobufs and some other Google pieces. And then also, I think we've developed a really great internal piece that has been open source called Kit, which kind of manages configuration hell for you for Webpack apps and Babel configuration. I've become a huge fan of Kit. But what we're here today to talk about is GraphQL at the New York Times. And at a high level, it's two parts. Our GraphQL server is actually a Sangria app written in Scala, which is maintained by a data team called Samistat. And we actually have a couple members here, somewhere in the crowd. I see one. And then the front end is currently a universal relay app. Then you're using Node and Express, and that's maintained by the team that I'm on. I joined the Web Frameworks team after we already had a running app with a few routes. And Olav from my team is somewhere in here. But he and our friend Jared McDonald from Web Frameworks originally spun up this app, and that serves as the basis of what we've been building for the past year and a half. So React and GraphQL at the New York Times, like why? And what's interesting is that the Last Replatform, these tools didn't exist, which is kind of crazy if you think about it, because it was only, I guess, 4 years ago now, maybe a little bit longer. And we've had some great talent at the New York Times on our graphics team. Jeremy Ashkenaz, who built Backbone and Underscore and CoffeeScript and all these great things. He worked with us for a long time. Michael Bostock, who wrote D3. And so we actually had a lot of momentum around building our apps, around the kind of the MVC architecture I think a lot of us were used to at the time, around Backbone. But our friend Olav and another friend, James Lowry from the Samistat team, were starting to explore demand-driven architecture a couple years later, and they were looking at things like Falcor. But eventually, there was momentum around GraphQL, and so we moved forward with it. We thought it was really cool. But GraphQL in some ways is still brand new, and organizationally, we're really still kind of figuring it out. So even in the year or so of implementing GraphQL, we've learned a lot, we have pivoted a lot, we've changed the way we view apps, we've drastically changed the way we work. We've changed, and the way we see the world has changed, and it's like really been this wild ride. And everything starts so innocent and simple. The GraphQL site kind of lays it out plain and clear for us. Gives us some guidelines, and it gives us some best practices if they exist. I'm not totally sure, but but an organization's thinking of muscle memory doesn't change overnight. So we're also, we're part of a big technology organization with, I think 300 engineers with all their own histories, preferences, ideas, and specialties. But GraphQL suggests a few things, which is, like we all know, prefer building the GraphQL schema that describes how clients use the data rather than mirroring the data. So in 2 original iterations, to get started, we do what a lot of people do, which we mirrored the data. I even did some side, little prototypes with WordPress. And the first thing I did was mirror the data because it's the easiest way to get started. You don't really have to think about much. And if you're going to do that, if you're going to do schemas like that, it actually makes a lot of sense to auto-generate those schemas because if in the REST mindset are still using these documented REST APIs. You don't want to be missing data when app developers go to use it. But with the luxury of time, you can create your schema gradually, making decisions about what to include and like what to leave behind. But another guideline is versioning. And it basically says not to version the schema like we do our REST endpoints. But because we're doing much replatforming at the same time to where we were going to have a whole different pipeline and based on protobufs, our first schema was really a placeholder until we had what we considered the real one. But because we did that, we ended up having to rewrite all of our apps, which is kind of like a one-time cost. But when your app starts to grow and gets bigger, that gets very prohibitive. So our main pivots were that we mirrored data, and then we versioned the schema and generated from protobufs. But then we decided to actually not do the protobuf thing. We wanted to give ourselves some flexibility so that we could give UI developers a little more flexibility in adding fields. But even doing that, we actually realized that we can go overboard on that too, because we took some of our design language and pushed it all the way into our GraphQL types. And if you go too overboard on heterogeneous types, or things like trying to type too much content, you can actually end up with really crazy fragment size and query size. So the other piece was Relay. And Relay was selected very early in the process. And that decision seems like it was a long time ago. But if you chart out Relay, it's only been a year and a half since Relay was open sourced, which is insane if you think about it. I mean, when I joined the team at the end of last year, even as we were learning the ins and outs of Relay Classic, there was a lot of chatter about Relay 2 and what was Relay 2 going to do. And Relay Classic seemed fine, but then you would watch a Joe Savana talk, and he'd say, this is why it's so bad, and here's why Modern is so good. And we just assumed that Relay Modern was going to do all these things for us. We evaluated Apollo lightly during this time, but the general consensus was let's wait and see what Relay Modern does. So Relay Modern dropped. That was Relay 2 that we'd been waiting for. And I was so excited. I ran to my computer that day to do a Hello World app, and actually Sasko did the same thing. So I tweeted this. Basically, we both made these little Hello Worlds. But one thing that kind of became clear, to us at least, was that Relay Classic was kind of dead. It seemed like all the momentum was going towards Modern. And Modern does have a classic mode, but if Modern was written because Facebook realized Classic was not built to perform, that really left us with two options for the future. So of course, Relay Modern or Apollo. And at this point, we still think we're going to update to Relay Modern. We have questions about the ecosystem, but we decided it might be a good time to kind of rethink everything around what we wanted to use for this data layer. So what became obvious to us when we started moving the times to Node, and I think you may all agree with this, is that the NPM and Node ecosystem moves extremely fast, and in the process creates kind of epic amounts of vaporware and abandonware. So we have to constantly reevaluate our decisions and assumptions when we're building a solid foundation for the future. And these frameworks aren't a one-line install. They end up being a collection of packages that enable stuff like single-page app routing, isomorphic rendering, and then advanced pieces like store rehydration and persistent queries. So I'm going to walk through some differences behind Relay Classic, Modern, and Apollo. And all of these projects work. There are trade-offs with each. All these platforms will continue to evolve, and I want to help evolve Relay and Apollo. But part of the job of evaluating what framework is right is understanding how these projects work, how they're the same, and how they're different. So the ecosystem around Relay Classic is not vast, but it does exist. Server-side rendering is actually a non-negotiable for us. Any decisions we make have to have server-side rendering in mind. And these are the routing libraries you need to make server-side rendering work with Relay Classic. So Relay Classic has a hard requirement on using a router in a particular way. So we specify queries directly on the route. And then for GraphQL strings, we use the relay.ql tag template literal. And the Relay Babel plugin does all the magic with parsing these templates into actual queries that we can send to our server. Queries in Relay Classic use kind of like this shorthand GraphQL notation. And this can be a little bit of a mind bender for people if you don't already have a vision of what the query looks like in your mind or in graphical. And then route params kind of automatically map from the path prop and are passed to the query vars, passed as query vars to the query. Fragments in Relay Classic can contain variables local to each instance of the component. So every time card media is rendered here, a different crop could be requested. These local variables can trickle down into child components and can actually be informed by parent components too. So this dynamicism is great for writing flexible components, but it has a cost of deferring a lot of work to Relay internally to transform these dynamic fragments into pieces of static queries that can be sent to the server. The query that gets constructed is a result of a lot of magic, and a lot of complexity is hidden from the developer. For instance, Relay doesn't send field aliases that you specify to the GraphQL server, but when you specify arguments on a field, it does alias those fields and send them. And knowing that these types of fragments exist is important for when we look at how these components are written in Relay Modern and Apollo. In Relay Classic, refetching and pagination are accomplished using one lone mechanism, which is set variables. And this is also how client-only data can be requested in Relay Classic, which is calling set variables and component mount and toggling isClient. Set variables is also what triggers the cryptic node query. And I would actually love to have a conversation with somebody, maybe you, Lee, about, can explain to me how, why, and when this works the way it does. I don't 100% get it yet. And my description is that mutations look like flux on drugs in Relay Classic. So we don't have time to talk about how mutations work, but this is how they look in Relay Classic. So that's a trip through Relay Classic, but we didn't look at the SSR part. And this is what you have to do on the server to extract data from your routes and then render the app with it. And I've abridged the implementation details a bit. But this actually ties us, because we need server rendering, we have to use isomorphic Relay Router. And that project actually has no plans to support Relay Modern, meaning it's abandonware at that point. I actually have a PR, so it even supports React 16. Because what happens here is that when a project becomes, isn't updated, isomorphic Relay Router actually wants an older version of React Relay Router, which has updated to support React 16. So because its dependency is off, and because React Relay Router uses React.prop types internally, we need somebody to upgrade there. So unless they modernize themselves, they can't be used with Relay Modern. And abandoning these libraries will take away that SSR piece, which we need. So Relay Modern is new, and it's a great project, but there really hasn't become an ecosystem around it yet. Found Relay is the Relay companion to the Found routing library. It does do a server-side rendering component, but a big reason it does that is I hunted down the author on Twitter DMs, and I was like, I need this, can you help me? So perhaps something that's not totally known about Relay Modern is that query renderer does not work out of the box on the server. So you actually need a similar mechanism to what isomorphic Relay Router does to get your data on the server so that you can do server rendering. Relay Modern does include a bunch of useful tools, stuff like query response cache, and there's also, let me go to this slide. It's a lot easier to set up the network pieces of Relay Modern and actually switch out with more advanced implementations once you have them. But we really need Found Relay to do this, which gives us a static route config so that we can extract the routes that have queries and hydrate that data ahead of rendering. So Component fragments in Modern look very similar to Classic, but use some different API methods, which I've shown here. Relay Modern uses a Babel plugin, but it's actually a different Babel plugin than Relay Classic does. And this introduces static fragments and static queries. So there are no more local variables, and variables are only passed at the top level of a query now. So all fragments need to be static at build time so that the Relay compiler can turn them into artifacts that the Babel plugin uses. This actually was already happening in Relay Classic, but it was happening because of that magic. So if you look at your queries that are being sent in Relay Classic, they actually look like static queries, but they were just assembled at runtime. So if we remember our dynamic component from Classic that had a local variable, that complexity goes away, but we probably have to rethink the portion of our app that deals with crops now. So unraveling that complexity has actually been a challenge for us. And there are several components that expected to only receive one crop. So the logic we were using to retrieve the crop from the result wasn't the greatest. So we actually may need to iterate over that list of crops now and find the one we're looking for. But Relay Modern also has more options than just set variables. So you can create a refetch container, which is almost the same API. And the documentation says this is good for load more. I think about refetch as more for inline updates, like a feature like search, or maybe doing that client-only data thing. A pagination container won't actually even fit on the slide, but it's actually pretty powerful because if you use this configuration, infinite scroll is really easy because you get this method where you can do just load more number of items, which is great. So mutations in Relay Modern actually use an imperative API that's very similar to Apollo's. Documentation is a little tough, and I think anybody that's tried doing mutations in any version of these has found this. I got lucky because I was able to read the code and kind of know what was happening internally, but I don't think every developer is going to do that. So here's an example of Relay Modern updating their store, and you kind of have an option. You can use these cryptic Flux configs, or you can do the connection handler API like this. I got it to work, but I actually have no idea if this is correct. It's kind of like filing my taxes. It happened. I don't. Is anybody right here? So at this point, we have some knowledge about Relay Modern. But we have a routing library that's version 030 alpha 9. And we realized our GraphQL schema does not totally jive with the response normalizer in Relay compiler. So we wanted to take a look at Apollo and see what Apollo could do for us. Jeremy Gayed, who's one of the lead engineers at the Times, had done an initial review of Apollo and had been impressed. But a lot of us were skeptical because we were waiting for Relay 2, so we kind of blew that off. But what happens too is that the Times code base already is too big to try out a new framework. So these, Relay and Apollo have these idioms that kind of extend everywhere. So it's hard to just pick one piece to run part of the framework on. So I actually did some projects on the side using WordPress to where I made a Relay version of a theme, I made an Apollo version of the theme, and I used React Native as well to kind of try this stuff out and see how easy it was and what the ergonomics were like. So I enjoyed Apollo, and I felt like it was natural. And what was nice, though, is that every time I hit a corner case in the app where I needed to reach out for a package, there was an ecosystem around it. So with Apollo, you can use any router you want. And this actually includes React Router version 4. So anyone that's used Relay with those other tools I showed for Classic, in React Router version 4, static route configs don't really exist. So using React Router version 4 with Relay and needing server-side rendering is kind of an anti-pattern right now. In the case of React Native, you don't have the same problem. You don't have the server client limitation, so you can treat everything like it's client only. And the same is true for React Native and Apollo. And And Apollo Client 2, which just dropped, we have not upgraded to that yet. So most of what I'm going to show you is based on Apollo 1. But our router loses all of its complexity. None of the data fetching is tied to the router itself. So you can use any project you want for your routing needs. And when you want to do server-side rendering with Apollo, there's a one-line change here, which is SSR mode equals true, which is pretty amazing. And when we do it on the client, it's even easier. We can actually just reuse that state we got from the server. And there's great docs around this too about how you set up this in your template to read that data. So queries become decorators on components, and they don't need to leak all the way to the top of the route. So they can live anywhere in the tree that you render a component, and the component itself handles the loading and error state of each individual query, which that's also in a lot of these frameworks, the router is handling that for every route. Client-only queries are easy to specify. So one of the only reasons we use relay set variables is to toggle is client during component did mount. So when Apollo is walking your tree of React components on the server, it will skip requesting a query that has SSR false. And this is huge for us. In Relay Classic, we had to specify these queries on the route conditionally. We kind of, in a few places, awkwardly had to call set variables to toggle certain nodes within a top-level query. The GraphQL decorator makes it easy to provide data to a component deeply nested in our overall tree, or even conditionally load React components and their data on the client in response to user actions. So we have a lot of modules that are maybe at the bottom, well below the fold, that we can defer until the user actually scrolls down there. And what's great about these ecosystem choices is that there's multiple choices available using Babel or Webpack to parse GraphQL fragments into their AST representation. The flip side is that Apollo does not enforce co-location of fragments and does not perform data masking on nodes like Relay does. And this is one area where knowledge of Relay really helps, because co-location is a great practice for ensuring that you are only requesting the data you need for a component. Fragments in Apollo can be placed as static members on components, but this is not required. It is a good convention so that your fragments can be easily imported into other components, like so. But there's also this option of using GraphQL tag/loader. That's where you can specify your GraphQL queries and fragments in separate files, which is nice and very tempting. It is also possible that there is too much flexibility allowed by Apollo here. So it's really up to your team to enforce your relevant GraphQL fragment standards on your project. Apollo does not require any special container logic before exposing these fetching APIs. You always have access to refetch and fetch more on the data prop. So I'm going to skip describing mutations in Apollo. They're an advanced topic, and documentation on Apollo's site is more exhaustive than it is elsewhere. But what's also important for us around documentation is that when we onboard new members on our team, we want to be able to point at documentation for a lot of these things. One of the biggest fears is that a small number of people become experts, and then somebody leaves the company, somebody goes to a different team, and you have this small cadre of people that held all that knowledge in their heads. So when we pick these frameworks, it's nice if with just pointing somebody at some documentation that says, please read this article about Apollo or Relay, go here to understand how these things work, or even providing tutorials. So another problem, once we've picked our framework and we've figured out the ergonomics of composing queries and implementing features like refetch and pagination, we're still left with some challenges around data in React. I recently wrote a manifesto about how frustrating dealing with HTML can be in the React and GraphQL universe. So for organizations that have many years worth of content in their CMS, it's often the case that the data, for whatever reason, and I'm not going to name names, this is a safe space, but that data will have a lot of HTML in it. So free-form HTML can appear in many forms, permutations, varying degrees of complexity and safety. And some free-form HTML is harmless. Other bits simply won't survive the trek from database to React render. And some free-form HTML contains JavaScript. And some free-form HTML was composed using JavaScript for a certain target platform. And so without the platform, it's actually missing context. So one way to deal with HTML is to parse it into structured data. And the New York Times actually implements structured data as a pair of types. And basically what happens is that our editor in our main CMS, which is called Scoop, we have a new WYSIWYG interface to where you can enter content, and then there is tools around adding an image or maybe adding a tweet, and actually getting a JSON representation of this. So we have two types, block union and inline union, and they're both heterogeneous and represent n other types. This allows us to render HTML into proper React components, but heterogeneous types can create extremely complex GraphQL fragments, and they can create very large queries when composing them. We have some queries that can get as big as like 15K, 20K. And this is why persistent queries, where we only send the ID of the query instead of the whole body, is essential for our long-term data strategy. The depth of any particular blob of HTML nodes is mostly unknown before you parse it. So creating proper fragments to query all available data can actually be complicated, because recursion of unknown or infinite depth is actually an unsolved problem, I think, in GraphQL. And somebody can correct me if that is not so, but it appears to be the case. So scripts in HTML, which are not something we like, but something we have to deal with in some form or fashion, because a big portion of our New York Times freeform HTML is actually some of our most popular content. So the New York Times is obviously known for its compelling journalism, and is often lauded for its interactive and visual storytelling. And so many of our assets, like charts, graphs, and embedded modules, are actually built to render on the new platforms, the old platforms, in web views, kind of anywhere. They're supposed to be portable. And so in our move to React, one of the most challenging tasks we've had is to figure out how to take these generic modules and load them using React on the server and client without completely destroying them in the process. And these things do not always play well with React and isomorphic rendering. And sometimes it's not as simple as doing what we see here. And I think we've all done this any number of times, to where we get HTML and we think dangerously set inner HTML will do the trick. Your JavaScript will not execute. And a lot of times what actually needs to happen is that that string needs to be parsed. And if you don't have structured data, that string needs to be parsed, the scripts need to be removed, and you actually need a mechanism for loading those scripts asynchronously and then kind of setting state to re-render your content once the scripts are available. It's gnarly, but we're doing it. In React 16, there is some light here, because there's now a React DOM.hydrate. And so when you do server rendering and you use hydrate on the client, it'll actually reuse the existing nodes you have on the page without blowing them away. React DOM render does the equivalent of blanking out your target node before it renders it again with the client. So we've raised this issue with the React team. Yeah, so this has been our biggest headache probably for most of the year. And since our old platforms are still running, these embedded interactives work everywhere except our newest platform. A lot of these we've actually opted to load in these legacy modules, we call them, using iframes. And the iframe itself, because like I mentioned, some of this content can actually contain JavaScript that expects to be in a certain runtime. in that MYT5 environment I described, we had a require.js config at the top of the head. We loaded require, and so some of these embedded modules just call it require, assuming that it's already there. Like, what do you do when you're in React now? And we can't ditch all of this content. I mean, there's thousands of these things. So we've decided in iframe is kind of the best place. We have a route that loads, an express route that looks very similar to how NYT5 looked just for these embedded modules. But when we do that, we're essentially reverting our UI for the graphics team, to the days of Flash and Java applets. We give them a rectangle and say, this is all you get, which they're not thrilled with. So luckily, Seb from the React team exposed a dirty solution here for us. Apparently, if you call dangerously set inner HTML on the server and then call it with anything different on the client, it'll leave alone what you had in the server. So we're going to try that. I don't know that it will work. I will report back. So, we're in the middle of this hailstorm of replatforming. Like, we're really nowhere yet. But what's next for us? We're going to try to figure out React 16. And one of the problems there is that the ecosystem, are all of our dependencies ready for React 16? And the answer for most people is probably no. And for us, the answer is no. I mean, there's a handful of libraries that until they update, we can't even really try. And that's really the blunt truth of the Node ecosystem. It's great for a million reasons. That can be a frustrating part. We're going to continue following developments with Relay and Apollo, and maybe we'll help push the Relay ecosystem with all these pieces we need for server-side rendering and all that. But it becomes one of those things where if we do it, we kind of feel like we have to maintain it. So it'd be really nice if somebody else did it for us, obviously. In lieu of that, we'll see what we can do. And I have a lot of things. This is not me announcing this, but I kind of have this idea lab called GraphQL.WordPress, where I'm working on a bunch of projects to where I can open source kind of a solution for building a WordPress theme on Relay to where everything's kind of there for you to get started and you can build on top of it. Same with React Native. And that's mostly for me, so I can do projects for somebody and it doesn't take me much time. But I want to make it where it's easy to do that stuff. And I also really want to help solve some of these problems with the Relay ecosystem. We're going to continue evolving our schema. We're obviously looking at, is it worth it for us to try schema stitching? And I actually sent our team a picture of the Gramps slide from earlier from IBM. And some of the data guys were like, this is awesome. So we'll see what happens with that. This ecosystem moves so fast. CSS and JS wasn't even on our radar a year and a half ago. And so we're already seriously looking at the Emotion library, which launched in July. It's really insane. But I think we're all trying to solve a lot of these problems about what does it mean to be this enterprise level React app, and how do we optimize about getting rid of dead CSS and isolating our components to where they're really atomic units and all that. So the last little bit here I will say is we're hiring. All the jobs are at the top. I'll publish these slides on Twitter as soon as I get down, basically. But 2 feature teams I know for sure have the stuff I'm talking about. If you're interested in that, want to help us solve those problems. We have a home screen team. We have a story team. Our data team, I think, is in some form of hiring, and we have a couple of those members here, Jennifer and Jeff. We'll try to point them out as we're all talking. But talk to them about GraphQL and Scala, and they're using the Finagle project from Twitter. And I think that's it. So thank you very much.